the mighty North Saskatchewan. On the banks of this great river stands the Biological Sciences Building, a sprawling multi-winged complex dominated by the 11-story Tower of Zoology, boldly symbolizing the preeminence of the animal kingdom in the natural world. From all corners of the earth, packages arrived filled with samples of the vast botanical diversity of the planet, destined for the department's herbaria, where they are carefully stored in an efficient information retrieval system. An array of controlled environment chambers is used to simulate natural circumstances from around the globe, allowing researchers to experiment on plants under the most realistic conditions possible. On the zoological side, informative bulletin boards around the building give evidence of the frantic activity within. The elaborate Museum of Zoology houses a vast collection of deceased fauna, storing them desiccated or in specially formulated preservative fluids. Laboratories are equipped with the latest in lab equipment, and a digital computation facility capable of thousands of calculations per minute allows researchers to address important hypotheses in the evolution of vertebrates such as birds and dinosaurs. Ultimately, they seek the holy grail of biology, an explanation of the evolutionary ascendance of mankind. Vertebrates are not the only object of study in the zoology department. The stupendous numbers and diversity of the invertebrates attract many an esteemed researcher to even their most obscure parts. To delve into the finest details of the subcellular world, equipment such as the recently developed electron microscope allows researchers to read nature's closest held secrets, a veritable electronic Rosetta Stone. Protected by greenhouse glass from harsh northern extremes, living plants from even the warmest of climes are nurtured under the watchful supervision of an expert horticulturalist, reporting directly to the department head. The key to future research is to train future researchers, starting with their indoctrination at the undergraduate level, where long hours of methodical larval drudgery groom them for a period of creative and independent thought as pupil graduate students who metamorphose into fresh-faced, fearless young researchers. These, in contrast to their established and already prolific senior colleagues, are ready to brave all risks and test their academic mettle in the rough and tumble world of publish or perish. Let's examine some of the research being done in this department. At the most basic level, mathematics is the key to understanding. Here, we see the fundamental theorem of natural selection being derived by someone who works at the frontiers of knowledge itself. Next up the hierarchy of complexity are the molecules which form the building blocks of life, such as the twisted strands of nucleic acid known as DNA. Many are drawn to biology by their interest in actual organisms, and these intrepid naturalists are not afraid to get their hands dirty. Sophisticated simulations of animal interactions lead us to an understanding of population biology, the highest level of complexity. These interactions ford the gulf between the plant and animal kingdoms. From the largest redwood to the lowliest worm, all such interactions can be understood as forms of that most basic natural phenomenon, sexual reproduction. An excellent department such as this broadens its horizons by looking beyond its borders. Take, for example, the collaboration with space physicists on how to breed into humans the ability to resist the radiation that will result from the worldwide Bolshevik nuclear menace, should it ever come about. Let us leave the ominous realm of national security and comfort ourselves by delving into the details of a fascinating series of hope-inspiring experiments. Here, a researcher tries to resuscitate the extinct greater prairie chicken using advanced pyrophysiological techniques. It's a promising project requiring long hours of dedication and inventiveness. But birds cannot be saved in isolation. Some of them, such as this pelican, eat fish, so we must address this pelican's need for and interaction with a healthy population of consumable fish. By maintaining a captive population of fish and keeping careful track of the numbers of captive fish in the population, a researcher can then simulate the predation interaction between pelican and fish, representing the pelican's agile bill by a net, the wild fish by captive fish, and the lake environment by a modern aquatic holding facility. Equally important is to study the fish's point of view, where we ask how it sees this large bill or net, attacking repeatedly from above the water's surface. How does it escape? How does the bill affect the fish once the fish has not escaped? As we can see, these busy researchers' time is valuable, therefore we must not waste any of it, and so an efficient and rapid transportation system connecting all major facilities in the building is essential. Accurate measurements require clean surroundings. Departmental technicians work around the clock, maintaining the building's differential pressure cleaning system. Happy researchers are productive researchers, so capable staff provide friendly dictation and shorthand services. A trained crew of artists maintains the aesthetic atmosphere of the building, and of course, scientists are rewarded with a variety of culinary delights. But what happens when things go wrong? As with any major technical facility, safety is an utmost consideration. Highly visible warning signs are posted around the building, commanding those who are unqualified or unauthorized to access critical locations not to do so. To protect against sabotage, facilities are monitored around the clock by vigilant staff able to rapidly detect any deviation from normal operation. A central switchboard monitors operations and has direct hotlines to fire, police, Army, and Navy centers. Not all crises are serious enough to require external involvement. Most, in fact, can be dealt with internally, and easy-to-use equipment is located around the building so that minor contingencies can be readily contained. Committees from biological science and other departments on campus have established a plan by which the university deals with these potentially embarrassing situations. All staff are trained to secure critical assets in the event of an emergency and are given practical experience in containment procedures. This plan has been instrumental in maintaining the department's as yet unblemished public reputation. We hope you've enjoyed this short film introduction to biological sciences and will soon visit this department on the go.